Good afternoon and good morning, depends on where you dial into from. And welcome to a new session of a Megaport Tech Drop-In. I guess let me just again do a little bit introduction of this tech drop-in, and this is a official chat hosted by one of the solution architects from Megaport, and we aim to have 3 different sessions on each Friday, which in North America, Europe, and APAC, and it's pretty informal, just a chat about something happened in Megaport and some interesting discussions we had with customer and some products maybe. Please feel free to send us any questions or any topics you want to cover during this session or maybe next one. Today, I will be talking about the Global WAN by Megaport. It's probably combined with some concepts and customer use case and the scenarios. Hopefully that can help you really understand how Megaport Global WAN and the capability can help you with certain scenarios and the connectivity requirement. First thing first, a little bit about myself. My name is Morgan Wang, and I am pre-sale solution architect of Megaport based here in Melbourne. And I predominantly look after Megaport customers based in Victoria, Tasmania, and New Zealand. Here on the screen, my contact information, email address, and LinkedIn. Please feel free to drop me an email with any questions or anything you want to discuss about Megaport, or otherwise I can make an introduction to your probably local solution architect or sales executives from Megaport. Before dive into the Global WAN topic, I probably cover some high-level introduction or maybe Megaport 101 of who are we and what do we do. Just in case you are not familiar with Megaport products already, and you first time heard about us and join into this session as well. So Megaport is actually now ranked the #1 global network as a service or software-defined network as a service provider. And we also #1 data center connectivity provider globally. This slide is a little bit outdated. It's only from probably 4 months ago, roughly, or 6 months ago. But last month, we officially announced that we are now in 1,000 data centers globally. That's roughly 10% of all the data centers globally available. And we are in across those 1,000 data centers, we are in 26 different countries. And with those 1,000 different data centers, we actually interconnect with public cloud providers on over 300 on-ramp locations now. So with all the infrastructure, apparently we have interconnected those 1,000 data centers and control them with our control plane, software-defined control plane. With all this infrastructure ready, we can provide a customer a really cost-effective and flexible network connectivity from any data centers to their designated maybe data center, maybe cloud on-ramp locations, or maybe Megaport partners or customers who are also using Megaport services but choose to publish their service on Megaport Fabric as a marketplace. And not long ago, Megaport also announced, I think this is probably very special to APAC customers or to Australian customers. For those customers who do not actually have a rack in that center, but do have racks or physical servers in their head office or in their warehouse, we can actually by leveraging our connectivity partners to extend our connectivity or fabric into customers' locations with last mile fiber. This is something actually, sorry, you can see underneath the diagram. That's something really new. Yeah, you can see that. Yeah, right. That's roughly the capability. And across Megaport offering, we actually categorize now our product into two different categories. One is access service. Access service is basically where customer can initiate their connectivities from. So typically, and also as beginning of Megaport, we only exist in data centers, and the customer also only consume our services from a data center. So that means the first access service apparently is a data fiber. Is a data center. A physical port in that center or pair of ports in that center. From the port, you can actually initiate up to 100 different virtual connections to different destinations, maybe another data center, maybe a cloud provider. And with customer introduced more like scenario and multi-cloud strategy or pure cloud strategy. Not necessarily all the customer have a data center now, but they still need to connect into really different SaaS provider or different cloud provider. So there are two different flavors of access service now available to the customers. One is a Megaport Cloud Router. Another one is Megaport Virtual Edge. So essentially, that's a virtualized application hosted on Megaport platform. If you don't have a data center, you can leverage Megaport Cloud Router or Megaport Virtual Edge to interconnect your public cloud tendencies, or maybe interconnecting your public cloud with your partner, with your provider, or with your third party. The differences between the cloud router and virtual edge. Cloud router is more like a simple routing instance managed and maintained by Megaport, where a customer can configure certain things through the portal, and they can see the usage and do the config changes through the portal directly. But if the customer have more complex scenario or connectivity requirement, and MCR might not be a good choice, in that case, MVE would be a good replacement. MVE is essentially the same platform we host MCR product, and we open up that to our customers so they can bring in customers' own choice of network function virtualization appliance to the platform. For example, it can be a router, it can be a next generation firewall, it can be a SD-WAN edge device, and from that device or from that specific appliance, customer can still initialize connectivities to same kind of destinations, but they will have more control on the routing, on the security policies, on certain things, because customer will have access to the virtual appliance and actually log into the virtual appliance to configure themselves. And of course, customer also need to bring their own license to the virtual appliance, so they can actually choose to have that running as a firewall or as a SD-WAN edge and with a certain performance, I guess, licensing. From those free access services, all the connectivity actually essentially are VXC. That's Megaport terminology, virtual cross connections. So you can actually establish a VXC, as I mentioned, to cloud, to another data center, or otherwise you can initiate a VXC to Megaport IX, Mega IX service. That's our own internet exchange server where we have basically IX set up in all the major cities across APAC, and the customer can participate with peering with all the other peers, which is a good actually a resource for customer to offload their internet-facing traffics, because all the other peers are just a one hop away through the IX, and it's actually free of charge. The other thing is Megaport Internet. We do provide the internet to our customers now, and there are a lot of things to talk about Megaport Internet. It's probably worth another different session or separate dedicated session for the internet. Not only this destination prepared by Megaport, but also if the customer choose to use Megaport and choose to allow other customers to connect into their own services or own environment, we have a marketplace that the customer can choose to publish their maybe port, maybe MCR, maybe MV, and all the other customers can search their name on the portal and initiate a connection request through this access service. Or otherwise, if you don't want publicly just to make that available to all the customers, you can create a private service key and share with your specific customer or partner. They can still initiate a connection request to your service, but it will be not available to all the other people or all the other customers. In terms of connectivity model, it's quite simple and straightforward, because essentially we provide layer 2 connections between all the endpoints on the Megaport fabric. So it started with DC to DC. That's we just two physical ports, one in each data center, and you just connect them with VXC. And the DC to cloud, the cloud essentially is a interconnection point we build with different cloud provider, and we can help you to connect into the cloud provider without physically into the same data center with the cloud provider, or without physically run a cross connection into that cloud provider's environment. Internet is just another option, as I mentioned. Another thing is a DC global backbone. That's basically leverage our footprint across 26 different countries and over 1,000 different data centers to allow a dynamic and globally reachable network built within 1 minute. Today's topic apparently is a global WAN as a service. Actually, global WAN as a service, to my opinion, is not a product that Megaport offer to customers. It's more like a concept with a combination of multiple capabilities customer can leverage and build their own network, depends on their specific requirement. It's very straightforward that with Megaport backbone, we can connect over 1,000 different data center locations. And we do have a protected path into each of the data center. So that means all the VXCs provisioned for the customer, they are by nature protected by our diverse transmission paths. And also, customer can leverage our other virtual access services like a cloud router or like a virtual edge to do some special routing configuration or manipulation on the whole platform. For example, SD-WAN, that's probably one of the most popular topic we have with customer nowadays. If the customer have their own SD-WAN network, and it basically means they do not require any private MPLS connection into data center to connect into cloud. But for the matter of connecting to cloud privately, they probably still need to maintain a rack in the data center. But with this MVE loaded with SD-WAN appliance, customer can actually use that virtual head-end to talk to the rest of the SD-WAN overlay network. And on the other side of the MVE, it can be a private connection directly into cloud without a rack or a physical router in any data center. That's probably something customer can leverage as part of the Megaport offering. Yeah, this concept is basically let's say a fiction customer who have multiple regions globally, and would predominantly use actually hybrid cloud environment, data center plus Azure. And you can see that the customer can actually interconnect. So first thing is the customer can actually connect into their Azure tenancy from local data centers, local data center physical ports. And also they can interconnect their data centers in different regions through Megaport backbone. Not only that, they can also use MCR, the cloud router, to route traffic between public cloud and the different regions and data centers. So everything is more like well controlled rather than point to point, and you have to provision a dedicated connection for any specific route direction. This is probably a kind of like an ideal scenario where a customer only use one cloud and they have a similar setup across all the regions, two data center pools and global connection. I'll probably introduce some typical customer or example of customer setup to probably I guess as a start point for you to consider how can leverage Megaport global WAN capability. So we have this customer. They actually have data centers, physical data centers in North America, in Europe, specifically London, and in Australia. Australia, they have actually two cities, Sydney and Melbourne. That's actually a very typical Australian-started global company expanded to Europe and American. And the requirement is to interconnect those data centers so they can transfer data between North America, Europe, and Australia. Also, as American it's a big country to operate, they do have some branch offices, and those branch offices require to connect into North Americans' local data center to feed in some data and get some data out from the DC. So the typical connectivity model would be you have protected point-to-point connections between all the data centers, right? So first thing is then you have the shortest path from A end to B end. And second thing is you always have protection just in case one path goes down, you have another one still up and running. Yeah, this is quite a typical setup and requirement from the customer. And also on top of that, the customer needs probably some private connections into the North American data center from branch offices. That's basically customers' concept of how to set up their whole network. Of course, you might think this is too much, right? So many intercontinental connections that could be really, really expensive. I could optimize the protection by reducing the intercontinental connections to build a ring, so that if one data center has one leg goes down, it has another leg to route traffic, basically detour to another path. But potentially, you will be facing a really increased latency if you actually fail over to another path. Imagine if the London and American path goes down, all the traffic will go through Australia and back to American. That probably potentially increase latency by 300 to 400 milliseconds. And after the discussion with the customer, we want to probably optimize the connectivity by introducing two MVEs in the North America. That's basically to talk to the branch offices through SD-WAN overlay network. So that removes the requirement to build private connection from branch offices into the data center. Of course, the MVE not only can act as a SD-WAN edge, it can the SD-WAN edge also has some built-in basic routing functionalities. So it can connect into the data center in London. It can also connect into the data center in North America. So all these three portions are now talking to each other. And we can also have pair of MCRs built into Australia, just for a redundant solution to allow the two cities talk to each other, Melbourne and Sydney. And for the really long distance, long haul transmission, we can actually consolidate into just the two links from the Australian-based MCR to American-based MVEs. So that's basically simplified the connectivity and reduce the cost by removing a lot of, I guess, intercontinental point-to-point connections. And in this case, some concerns normally come from the customer. I'm using my MVE for multiple functions. That might be the first thing is the performance that might be a concern. Another thing is security that might be another concern. And based on that, it can be optimized if the customer really care about, or maybe should I say, really focusing on the security and performance issue. Should this throughput getting really, really big? So we could have another pair of MCR. So just the service chain, the MVE between MVE and MCR. MCR only for the private routing between different sites. So we can move the data center connectivity all on the MCR and leave the MVE to only deal with the SD-WAN overlay between branch side and the private network. And the MVE will only talk to the MCR, so that's set up the boundary on the MVE. And this is actually really recommended by all the Windows don't. If you try to bring in your branch side and remote users, you don't just mix them together with all your private traffic, if that makes sense. Yeah, I might pause a little bit to check if there is any questions. Oh, good. Right. If there's no question, I'll probably move on to the next one. This one is actually the outcome of the discussion of what the customer want to do with Megaport and how to interconnect their different data center and remote sites on the Megaport network. And of course, with all the VXCs interconnect different continents, customer have the flexibility to spin up and down the speed when they require and how they require. Another customer scenario is actually, I guess this is a combination of different customer discussions. And it's quite common now. Customer have their own, like they are like a AWS shop. They have everything AWS, North American and Australia. But after acquisition or merger, they probably need to adopt a different cloud provider, in this case, Google Cloud. So the thing is how to interconnect their cloud services together. And locally, Megaport MCR would be a good choice to interconnect all the public clouds in Australia and in American different regions. And essentially, the customers still want, because if they are AWS house, they can use AWS to interconnect multiple regions. AWS provide that kind of service, but now they are multi-cloud. So they have two choices, right? One is they build a similar thing in Google as well. So they have two backbone, one from AWS, one from Google. Another thing is that another option is that they can consolidate that into single sets of long haul transmission, potentially can reduce the cost of oversubscribed international bandwidth. The other scenario is since you have the MCR, so customer have the flexibility to connect into multiple clouds, because a lot of customers now have multi-cloud strategy. They might from time to time need to consider, would Azure be a good fit for my certain scenario, or would the Oracle be a good fit for my certain scenario? And MCR can just simply have another pair of connection into a different cloud, and that will allow customer to start to set up POC in another cloud and join that into their current setup. That the two examples I just mentioned are just are all based on international connectivities, but we do actually have a more typical scenario in Australia plus New Zealand because I look after a lot of New Zealand customers, and it, when a customer have a data center in New Zealand, now they actually can consume AWS and Azure directly from New Zealand because AWS and Azure made the service available directly from New Zealand. But not for all the cloud providers. For example, Google, you still need to come all the way back to Australia through the Trans-Tasman, and Oracle as well. And Oracle, if you want to set up a location-based service, not only Trans-Tasman, you also actually need to consume resource from Melbourne. And in that case, customer need to subscribe multiple Trans-Tasman bandwidths for the cloud access. And to optimize that, we can help customers set up a cloud router directly closer to Google Cloud and Oracle, probably in Sydney or Melbourne. And there are multiple benefits from this cloud router. First thing is that you can actually optimize the latency between Google and Oracle, not necessarily bring all this everything all the way back to New Zealand and then send back to another cloud. The second thing is that you can actually optimize the bandwidth between Australia and New Zealand so that because the inter-cloud traffic won't necessarily need come back to New Zealand. Another thing is you don't necessarily need to reserve bandwidth for each of the cloud. You can actually have a bigger pipe reserved for two clouds. And also, because this is a private connection, only exists on Megaport fabric. It's not like a fast connect or Google Interconnect. So you can actually change the speed anytime you like. For example, after 5 o'clock, you can actually just reduce the speed, and 9 o'clock in the morning, increase the speed back to your production requirement. So that's something. It's not entirely a global one, but it's a small portion of the global connectivity that customer can leverage Megaport Fabric. Yeah, I guess that's probably everything I want to talk today. I might get into demo because I might get into demo because it's usually to the customer it sounds very complex and heavy duty to set up a global kind of a network connection. Where what I can do is, or with Megaport, what you can do is actually leverage Megaport's API. So I actually have a Terraform running in background. Apologize, I can't actually put that on the screen sharing. But with that Terraform script infrastructure as a code, I can actually spin up multiple services within a couple minutes. And in that case, I am actually now running my code. It probably takes 30 seconds or 1 minute before the service start to pop up in the portal. But in the meantime, it's actually it's still coming already coming up. But in the meantime, even you don't have a like a full list of services you want to spin up with Megaport, or you don't have infrastructure as a code setup, you can still easily I guess place orders directly through the portal. For example, if I click order, in this case, for the first customer, I want to order a report in London. It's just easy as choose your location, choose your speed, give it a name, and choose your term. In some locations, you can have Megaport to organize your cross connection from our demarcation point into your rack. Or otherwise, if a customer have a closer relationship with a data center operator, they can do that themselves. And we can also create a diverse pair of port that's actually will be placing a pair of ports on different hardwares, so provide the customer this electronic-based redundancy. Yeah, that's easily just a order process for a pair of port in the same data center, one in red zone, one in blue zone. And while we're talking, in the backend, my script actually also trying to populate more services to form the global WAN connection I introduced in the session. So you can see that I have my MCR Los Angeles blue and MV red. This MCR red and MCR Sydney blue, MV Los Angeles blue, and MCR Sydney red. So basically, now the script's still working. Try to build all the VXCs between MCR and MVs. So in the real world, roughly within 10 minutes, I could have this. Let me go back to that. Roughly in 10 minutes, I could have this whole setup up and running. All right. Sorry, I probably run over a little bit again. And that's pretty much everything I want to talk to you today. And thank you very much for your time. And have a great weekend ahead. We'll probably see you next time very soon. Thank you. Bye.